Today, I want to talk to you about why I think that science is actually part of culture. And I want to start by introducing you to this man. This is Sir Harold Kroto. He discovered fullerenes, also known as buckyballs, a phenomena that revolutionized our understanding of chemistry, and indeed the universe more generally. For his efforts, he was awarded the Nobel Prize in Chemistry in 1996. And Sir Harold, as it happens, was just in Singapore, as it turns out, on this very stage. So here he is, right here, pretty much sitting exactly where I'm standing right now 2 days ago. And in the talk that he gave here as part of the Nobel Prize series, he argued passionately for a dialogue between the arts and sciences. And he uttered something that I found extraordinary. He said, there's only one difference between art and science. In science, the universe is in control. In art, you are. Now, I want you to keep that statement in mind over the next few minutes. The reason why that matters to me is that I run this place, the Art Science Museum here in Singapore, and we exist to explore the intersection between art, science, culture, and technology. And in fact, that's something that I've been doing pretty much my whole career as a director of arts organizations and a curator. I tend to work with artists and other creative people on works of art like the ones that we're looking at now. These range from exhibitions, such as the Da Vinci exhibition we had at Art Science Museum, to new commissions and productions by filmmakers, artists, and also scientists and technologists. I'm always interested in showing that science and engineering is about more than just tools and technologies. It's about perceiving the societal transformations which are being brought about by technology and indeed by science. Now, I should also admit that I also am an artist. I like to think of myself as retired now, but this is when I was practicing with the group Radio Qualia. And we mostly worked with sound and radio, and indeed the science of radio astronomy, as well as making tactical media and community radio projects, sometimes in somewhat extreme locations. So this is us setting up a community radio station in Antarctica. And I have a sort of a deep and abiding love of science. I write about it sometimes at this blog, Particle Decelerator, mostly about physics research. But generally, I'm interested in what happens when artists and other creative people are thinking just as hard about science and technology as the scientists and the engineers are. So what I want to do today is briefly show you some examples of where science isn't just influencing culture, art isn't just illustrating science, but science is actually becoming art. I was a keen reader of the Seed journal, sadly defunct, and its byline was Science as Culture. A few years ago, I happened upon an extremely interesting article in Seed by the neuroscientist, now sadly disgraced, Jonah Lehrer. And in it, he argued passionately for an experimental culture that deliberately crossed the boundaries between the arts and the sciences. Lehrer spoke of a positive feedback loop in which works of art led to new science experiments, which then led to new works of art, and so on. His argument was that art could provide science with a source of scientific ideas and valuable tools to model theories so that we can better understand their consequences. Art could take scientific metaphors beyond the merely metaphorical. He insisted that every physics department should have an artist in residence, and the art galleries should be filled with disorientating evocations of string theory, a particular kind of physics theory. Well, as it turns out, that culture is actually here. This is the artist Conrad Shawcross and his beautiful kinetic evocation of that physics idea, string theory. This piece is called Loop Systems Quartet. And we brought the work of Conrad Shawcross to Singapore as part of the Da Vinci Shaping the Future exhibition. Here's another example of what Jonah Lehrer was speaking about. This is the work of Semiconductor. Semiconductor's work goes beyond mere scientific visualization. This is a piece called 20 Hertz, which I commissioned. And this is a magnetic storm which is happening in the Earth's upper atmosphere. It's caused by the sun interacting with the Earth's ionosphere. And what you can hear in the sound here is very low frequency radio waves which have been turned into sound by a Canadian science institute called Charisma. And what the artists have done is that they've taken this sound and they've visualized it as a sea of vibrating particles. So the storm which is happening in the Earth's ionosphere, something which is unavailable to our senses, becomes something that we can feel tangibly in this artwork. We commissioned them to create a work for Singapore called Catching the Light, which uses data from space telescopes to give us windows into space-time. And this is another artist who's been at Art Science Museum this year. This is Jeremy Sharma from Singapore. This is his work, Lilith, which is a depiction of a pulsar, a spinning neutron star. Pulsars are short for pulsating radio stars, and they're highly magnetized rotating neutron stars. Neutron stars are extremely dense. They may only be the size of, say, the state of Texas, but a neutron star that big will have the same mass as our sun. And all of that mass, very, very densely packed in, creates a huge amount of energy. And this energy causes the neutron star to spin on its axis. They can rotate from about 1.4 times per second to thousands of times per second. And every time they rotate, they emit a powerful beam of radio energy. And we can detect that radiation here on Earth. So that's what you're listening to now. You're listening to a pulsar. This is B032954, one of my personal favorites. And the clicks that you can hear are the sound of the pulsar basically spinning on its axis. The signal of a pulsar can also be turned into a diagram. And this is a good example. This is the very first pulsar discovered by Jocelyn Bell Burnell in 1967 at Jodrell Bank. And Jeremy Sharma worked with scientists to obtain a whole series of these diagrams. And then he used those diagrams to create these stunning three-dimensional paintings. Now, Jeremy isn't the only artist fascinated by the distant universe. Artists enjoy pondering the mysteries of space. Here's the work of Katie Patterson. Just as Jonah Lehrer wished it to be, she was an artist in residence in a physics department. Katie's work really exposes the profundity which is at the heart of much contemporary physics research. She creates actions like 100 billion suns that try and help us comprehend gamma rays, the brightest explosions in the universe that burn with a luminosity 100 billion times that of our sun. She makes maps of all the dead stars, writes memorial letters to every star that dies, and creates installations that give people a lifetime supply of moonlight. This is Ancient Darkness TV, and whilst it might be a little bit hard to see, this is actually darkness from the edge of the universe broadcast on TV. Working with astronomers from the Mauna Kea volcano telescope in Hawaii, Katie sourced an image of ancient darkness and transmitted it on a New York television station for exactly 1 minute. It revealed darkness from the furthest point of the observed universe, 13.2 billion years ago, not too long after the Big Bang and long after before Earth existed. Katie's work expresses a fascination with how we can look back in time through telescopes to a point before we and the Earth existed. She's intrigued by the fact that there's never a way to directly observe what's going on in the deep universe right now, this moment. We can only look into the past. Having operated in this in-between space where art and science collide for most of my career, I find the idea that art can be a crucial source of scientific ideas extremely powerful. But could the reverse also be true? Could science itself, the material, processes, theories, be a form of art? Well, I think it can. And this was one of the motivations behind Laboratory Life, a project we produced in the place I used to work in the UK, Lighthouse. We transformed our arts venue into a biotech laboratory, populated by doctors, engineers, and artists who worked in collaborative teams for 2 weeks. The teams cultivated bacteria in giant agar dishes, bred fruit flies for astrobiological experiments, and, as we can see here, attempted to tattoo DNA. The public could visit the lab and watch the magic happen. And here, science in action had become a cultural process. The results of what the teams produced began dual lives as cultural artifacts or artworks, and also as the seeds for what may at some point become scientific papers. And speaking of science papers, let me introduce you to Tam Peng Can. So Peng Can is a student from the National University of Singapore in the Centre for Quantum Technologies. And this is Peng Can speaking at Art Science Museum last September. And what he's talking about here is really quite extraordinary, because Peng Can solved a 50-year-old problem in astronomy. And he did it not with a vast telescope, but with a homemade setup comprised of cheap lenses and electronics. Peng Can became the first person to experimentally prove that light from the sun or any star moves in bunches of photons. Astronomers have been trying to experimentally prove this for 50 years, and Peng Can did it last year. That a student from Singapore solved such an important problem in astronomy using quantum optics is a very big deal indeed. And the applications of this research could be highly significant. Peng Can and his colleagues internationally now think that this work might give us a new method of being able to detect planets outside our solar system. So this is a science student from Singapore solving a 50-year-old problem in astronomy, presenting his work not at a science conference or a laboratory, but in an arts venue. Here, science itself has become culture. And the place where Peng Can works has some form in this area. The Centre for Quantum Technologies actually have a strong track record of working with artists. Their former writer-in-residence, Eleanor Wong, is speaking at Art Science Museum next Saturday at an event on particle physics. They also hold filmmaking competitions that encourage filmmakers to make movies about quantum physics. So as we can see here and abroad, the intertwingling of art and science is becoming ever deeper. And we're not alone in thinking that this coming together might be a bit of a trend. In 2009, legendary physicist Freeman Dyson set out a vision for the future. He argued that if the dominant science of our age is biology, then the dominant art form should be the design of genomes to create new varieties of animals and plants. He called for a new generation of artists who could write genomes as fluently as Blake and Byron wrote verses. He wanted to see artists who would create an abundance of new flowers, fruit, trees, and birds to enrich the ecology of the planet. Well, surely you must be saying to yourself, now this is a bit far-fetched, right? Well, no, as it happens. This is the Tissue Culture and Art Project, a collaboration founded by the artists Oren Katz and Ianit Zur in Australia. And they work with the very fabric of life itself, creating new biological forms using techniques such as tissue engineering. And whilst they're not quite capable of writing genomes for new creatures, they're certainly sculpting with the material of life. And there's a lesson in here, and that's that it's often in the field of art that we see people enacting the famous phrase that the best way to predict the future is to invent it. Nowadays, artists are sculpting with biotech. They're making solar-powered 3D printers, paintings with nanotechnology, radio stations with bacteria, and inventing sailing drones designed to collect oil from spills. These are the people who are actively engaging with the dominant social, political, and environmental issues of our day, and they're helping us see that science itself is culture. So to bring things to an end, I want to start by returning to Sir Harold Quoto's quote. When I posted this quote on Thursday, the great Singaporean writer and poet Alvin Pang immediately responded. Alvin had a slightly different take on this. He said, "Science is what the universe tells the human mind. Art is what the human mind tells the universe." Either way, somewhere in between these two sentiments, science has truly become culture. Thank you.